Alright, so yeah, we'll cover a couple of main topics. So here in the first slide, we're gonna cover two things: what software quality really means, and the main quality factors we should look for. I think we'll use an example, the campus tutoring scheduler. We'll use that example in these topics. So when people hear quality, they often think no bugs, but software quality is bigger than that. Software quality means the software consistently does what users need under real conditions with acceptable risk. So even if an app has few bugs, it can still be low quality. If it is slow, confusing, insecure, or hard to maintain, so like imagine for the tutoring scheduler works perfectly in your tests, like no bugs, no crashes, but in real use it takes like 12 seconds to load available times, or we can't students cannot figure out how to cancel a session. uh, User data is not protected well, so the app is not high quality even if the code runs without errors. So quality is about full experience and real world outcomes, not just it works on my machine. And when it comes to software quality factors, so quality factors are main areas we use to judge whether software is good enough for real use. So first is the reliability. So reliability means the system works correctly and consistently over time, especially under normal and heavy use. And then we have usability. Usability means the software is easy to learn and easy to use without constant help. Like for example, in a tutoring scheduler, if a student cannot quickly find book session, or the button labels are confusing, they make mistakes or stop using the system. So good usability means clear labels, predictable navigation, and helpful feedback, like booking confirmed. So those type of things. And then we have maintainability. So maintainability means how easy it is for developers to fix bugs, add features, and update the system without breaking other parts. um, and performance. So performance is how fast and responsive the system is. It includes load time, speed of searches, and smoothness of interaction. And then we have security. Security means protecting the system and data from unauthorized access and misuse. So, like for example, for the scheduler stores student info and tutoring records. If anyone can access another student's booking, that's a serious quality failure. So security includes safe logins, role-based access, and protecting stored and transmitted data. So quality is not just like no bugs, it's reliability, usability, maintainability, performance, and security working together so that the software performs well in real life, not just in testing. So that's about that. And next we have again we'll discuss two topics here: how we assess software quality, and the quality dilemma, meaning why teams struggle to decide what good enough is. And we'll use here an online banking system for example. So quality assessment is based on human judgment. It answers, does it feel right for users? It uses feedback, reviews, and observations. Like in banking application, you run a short user test and ask people to check their balance, transfer money, find recent transactions. So you watch what happens and collect comments like, I can't find the transfer button, or this confirmation message is confusing. So things like that. Uh, so these are not numbers. They are important because they reveal real problems that metrics can miss. Uh, and then we have quantitative assessment. So quantitative assessment is based on numbers. It answers, can we measure quality? It uses metrics like speed, error rates, uptime, defect counts, security indicators. Like for in the banking application, you measure login success rate, time to load account page, crash rate, number of failed transfers, so things like that. So like you might targets might be, account page loads in under 2 seconds for most users. Crash rate is stays under 1%. So those are quantitative measures, basically help teams set clear goals and track progress over time. And then we have software quality dilemma. So the dilemma is that quality is always limited by time, money, and risk. So you could you could keep improving forever, but projects have deadlines. So teams must decide what level of quality is acceptable. So what is good enough? So good enough is basically means the software is safe and reliable enough for its purpose. Even if it is not perfect, it does not mean sloppy. It means meeting the most important requirements and reducing major risks. Um like for example, now in the banking app sometimes shows wrong balance for few seconds. That's not acceptable. But if the app's theme color is slightly inconsistent on one screen, that might be acceptable for the first release. So good enough depends on the impact and risk. So next we have cost of quality. So improving quality has a cost. So it can require more testing, better tools, more time, more experienced staff. But low quality also has cost like support tickets, refunds, legal trouble, or loss of trust. So if a bank rushes the app out without even enough testing, customers might, get logged out. A transfer may fail. So fixing problems after release is usually more expensive than preventing them earlier. And then we have risk and the link between quality and security. So security is a part of quality. So a system can work but still be low quality if it is insecure. Security problems are high risk because they can cause real harm. uh, like in the banking, if the banking app has a weak login system, an attacker could access accounts. That is a quality failure even if the app runs smoothly. So this is why teams treat security issues differently than minor UI bugs. So security issues often must be fixed before release because the risk is too high. um, and we assess quality using both human feedback and measurable metrics. So the quality dilemma is deciding what is good enough under deadlines while still controlling cost and, reducing risk, especially the security risk. That's about quality. Uh, and achieving software quality and using reviews. So the difference between quality control and quality assurance and why reviews are one of the best quality strategies. Again, we'll use campus tutoring scheduler example for this. So first is how teams achieve quality. So quality does not happen by accident. So teams build it using two kind of actions: engineering methods and product management techniques. So basically, the engineering methods that improve the product, and project management techniques that control process, time, and risk. So engineering methods, these are technical practices that prevent bugs or catch them early. So in a tutoring scheduler, you engineering methods include clear requirements and simple design, so developers do not guess. Coding standards, so code is consistent and readable. And like automated testing, like unit test for booking rules. Integration tests to confirm booking or email and database work together. So secure coding practices like role-based access to prevent viewing other student sessions. So these methods reduce defects by preventing them or catching them early. And then we have project management techniques. So these are planning, tracking practices that protect quality by controlling the chain and scheduling realistic work. Like, for the like for example, in the tutoring scheduler, it's like setting priorities like must have versus nice to have, scheduling time for testing, review, not only coding, and tracking defects, fixing high risk issues first. So so if you only code and never plan for testing and review, quality drops even if the team is skilled. Uh, Next we have quality control and quality assurance. So quality control is about finding defects in the product. It's a detection, like it answers does the software meet requirements right now. And quality assurance is about improving the process so defects do not happen in the first place. So it's the prevention. So it answers like, are we using a process that produces quality consistently? So uh, and then we have reviews as quality strategy. So a review is one of the cheapest and fastest ways to improve quality because it catches issues before they become expensive bugs. Uh, and and the cost impact of defects, uh, and defect amplification, like the later you find a defect and it costs, it's the more it costs. So a simple mistake early can spread into many parts of the system, creating multiple bugs. That is defect amplification. And then we have informal versus formal reviews. So informal reviews are basically, these are quick checks like peer reading your code or short design walkthrough. They are flexible and fast. Uh, and The formal technical reviews is basically, these are structured review meetings with roles, preparation, and documented outcomes. So they are used for high impact work like core components requirements or architecture. Yeah. So and we have what is a review meeting uh, produces. Basically, a review meeting should produce clear outputs like list of issues, defects found, decisions made and why they are made, action items with owners, follow-up tasks such as fixes, rework, or additional tests. So those kind of things. So teams achieve basically usually teams achieve quality through solid engineering practices and good project management. So quality control and quality control finds defects, quality assurance prevents them. Reviews are powerful because they catch problems early before they multiply and become expensive. So yeah, that's about this topic. It's just the basic concepts.